Hey, so Paralyzed Math Industry, and we are going to take a look at another good theorem that we're going to talk about. It's called a right angle theorem. Okay, so before we learn about right angle theorem, we have to know why it's useful so we can get that aha moment. So, for a warm-up, we are going to do a proof, not a two-column proof. We're just going to use words. So if a median is given to us, we have to also prove that it also can be an altitude. And we're going to say that this is an isosceles triangle. So we could say that if it's an isosceles triangle, these two are going to be congruent. And it also means that these two angles have to be congruent. The line here said it was a median right here. So it will give us two congruent segments. However, if we prove these two triangles congruent, and we found out that these two angles are congruent, how can we say that they're 90 degrees? Because an altitude will bring you perpendicular lines, which will also bring you 90-degree angles. All we have here is we proved that this angle right here and this angle right there are congruent. Sure, 90 degrees are congruent to each other, but how can we prove that they are 90 degrees? Well, that is why we use a right angle theorem, because it will completely destroy the question of having, if they are congruent, then how can we prove that they're 90-degree angles? Well, with right angle theorem, we can understand and we can learn about this. A right angle theorem. If two angles are congruent and are both a supplement of the same line, then they form right angles. So here is a picture right here. And there are two lines. 1, 2. We are going to have to prove that angle 1 is congruent to angle 2. So if we already know that 1 and 2 are on the same line, and both of them have to equal 180, which is a supplement, so both are supplementary. If we say that angle 1 has to be congruent with angle 2, then what we can say next is we could say that this has to be 90 and that has to be 90 in order to be congruent and also equal to 180 degrees. If two angles are congruent and are both supplements, then they form right angles. So we say that angle 1 and angle 2 are congruent. We had to prove that they were 90-degree angles. So if we did angle 1 plus angle 2 is 180, if they're congruent, we can mathematically say 2x equals 180 divided by 2 and x equals 90. So we can say that if that happens and if those conditions are correct, then they must be 90-degree angles. Now we've understood it all. Now, let's prove ourselves by proving that we can do this, and we learned a right angle theorem. We have to rightly learn this by making a proof that will prove ourselves to understand this. Get the idea? So let's get started. Given EG is going to be congruent with GF. So, on the picture, EG is congruent with GF. Angle E is going to be congruent with angle F. So here's angle E, and here's angle F. Now we have to prove that DG as a segment is perpendicular with EF as a segment. So we have to prove that these two are perpendicular. I'm going to give you guys a hint. If we can prove that angles EGD and FGD are right angles, then we can prove that both lines are perpendicular, because right angles can lead us to perpendicular lines. So technically, here is our givens right here. What we could have done is we could make these triangles congruent to make another thing happen, another proof happen. So by finding the congruency of both of these two triangles to make more happen and more pizzazz happen, we can use the reflexive property using DG is congruent with GD. That would be this line right here, right there. However, we don't need to do reflexive because there's another one which will make a lot more sense. Notice how this is an isosceles triangle, and also notice how angle E and angle F are congruent to each other. That can also mean that ED and FD have to be congruent to each other. The reason why is, if we write ED is congruent with FD segments, we can say if there were angles that are congruent to a triangle, then it also means there are segments that are congruent in a triangle. So now we have the parts to prove a triangle. We can prove two things. We can say this two is congruent, this triangle, and we could also say this triangle has to be congruent to each other. So now we could say about that is, we have to say triangle, yep, that is definitely a triangle. GED is going to be congruent to triangle GFE. So GED is congruent with GFD. We're going to say that's SAS because we have segments, angle, segment. So now after that, we can also say that angle EGD is congruent with angle FGD. The reason why we say that, we can say CPCTC. So now we have proven that this angle and that angle are now congruent. But do you remember in the first part of the video where we got kind of stuck on that? We can say right angles are congruent. However, we can't reverse that. Because if you try to say that, then why is this angle congruent to that angle when it's 43 degrees? That is not going to be reversible. So we have to do something else about that. We can say that we can try and lead to our right angle theorem. So if we can do that, we have to prove that two angles are congruent, and they also have to be supplement. So in order to have a supplement line, or supplementary angles, we must have a straight line. So we can now then say that EGF is a straight line. We could say we assume that. We can assume straight lines. And then we can also say, if these are congruent and that is a straight line, we can now say that angle EGF GD is supplementary to angle FGD. Now we're going to say supplementary angles is going to bring us to 180 degrees. So if we understand that those two angles are supplementary and they're both congruent and also there is a straight line, we can now prove that angle EGD is congruent to FGD. We understood that. Well, we have to sort of expand on that. Instead, what we're saying is angle EGD is right. And we're going to also say that angle FGD is right. And now we have to use that proof, our right angle theorem. So we are going to use the equation congruent supplement angles is going to bring you right angles. See, congruent supplement angles is going to bring you right angles. So now we can transform these into right angles. And finally, we have hit the target and mission accomplished. We have now proven that DG is now perpendicular with EF. The reason why we can say perpendicular lines can bring you right angles. Wait, that's the opposite of what we say. Instead, we say right angles can bring you perpendicular lines. So now, if these are right angles, EGF is now going to be perpendicular with DG. So, these two lines are now perpendicular. We have completed the proof, and that explains the video. I hope this video has helped you understand right angle theorem. Thank you for watching Taoping Life's Math Industry. Like and subscribe.